We'll continue problems on DTFT.
Sometimes in the examination a question like this is asked. What is the sufficient condition? What is the sufficient condition for the existence of DTFT, existence of DTFT of x of n? Answer: the sufficient condition for the existence of DTFT of x of n is that x of n must be absolutely summable. The sufficient condition for the existence of DTFT of x of n is that x of n must be absolutely summable. That is magnitude of x of n when summed from n equals minus infinity to plus infinity should be less than infinity. This is only sufficient condition. If this condition is satisfied, DTFT definitely exists. If this condition is not satisfied, it doesn't mean DTFT does not exist because it is only sufficient condition. There are several time domain functions for which this condition will be violated, but still DTFT may exist. Using properties, find DTFT of x of n is equal to n into half to the power n into u of n. For doing this problem, frequency differentiation property you have to remember. See, minus jn into x of n has a discrete time Fourier transform dx of e power j omega by d omega. This is nothing but frequency differentiation property. This property you must know if you want to do this problem. We apply linearity property to this property. What I mean is multiply both sides by j. J into j is what? J square. J square is minus 1. Or this means n into x of n will have a discrete time Fourier transform j times d by d omega operating on x of e power j omega. Now we come to the actual solution. Recall a to the power n into u of n has a discrete time Fourier transform 1 over 1 minus a e power minus j omega. Hence x1 of n equal to half to the power n into u of n has a discrete time Fourier transform x1 of e power j omega equals 1 over 1 minus half into e power minus j omega. Applying frequency differentiation property we get. What is x of n? X of n is equal to n into x1 of n. will have a discrete time Fourier transform x of e power j omega equals j into d by d omega operating on x1 of e power j omega equals j times d by d omega operating on 1 over 1 minus half into e power minus j omega. Differentiate this using, what is differentiation of 1 by x? Differentiation of 1 by x is minus 1 by x square. Take this as x. So what you get? J into, I write j into minus 1 over 1 minus half into e to the power minus j omega whole square into differential of the inner function. What is differential of the inner function? Differential of the inner function is, differentiation of the inner function is what? Minus half into e to the power minus j omega into minus j. So this becomes now minus into minus plus, j into j is j square. J square is minus 1. So you get half into e to the power minus j omega divided by 1 minus half into e power minus j omega whole square. So what I have done is d by dx of, see what I have done is d by dx of 1 by x is what? Minus 1 by x square. This I have treated it as x. So I get minus 1 over 1 minus half into e to the power minus j omega whole square into differential of this. Differential of 1 is 0. Then differential of this is minus half into e power minus j omega into minus j. Minus into minus is plus, j into j is j square. J square is minus 1. This minus 1 also will go. So this is the answer. We go to the next one. Using properties, find DTFT of x of n is equal to half to the power n into u of n convoluted with 1 by 3 to the power n minus 1 into u of n minus 1. Solution. Recall a to the power n into u of n has a discrete time Fourier transform 1 over 1 minus a into e to the power minus j omega. Hence x1 of n is equal to, this one I will call it as x1 of n, half to the power n into u of n will have a discrete time Fourier transform x1 of e power j omega equals 1 over 1 minus half into e power minus j omega. This is called x1 of n. And x2 of n is equal to 1 by 3 to the power n into u of n has a discrete time Fourier transform x2 of e power j omega equals 1 over 1 minus 1 by 3 e power minus j omega. In fact, what is, I will call this is x1 of n, this is nothing but x3 of n. What is x3 of n? x3 of n is nothing but x2 of n minus 1. And this is nothing but x1 of n. Applying time shift property, we get What is x3 of n? x3 of n is equal to x2 of n minus 1. We'll have a discrete time Fourier transform. x3 of e power j omega is equal to e to the power minus j omega into x2 of e power j omega equals e to the power minus j omega into 1 over 1 minus 1 by 3 e power minus j omega. Applying convolution property. Applying convolution property, we get what is x of n? X of n is equal to x1 of n convoluted with x3 of n. Will have a discrete time Fourier transform x of e power j omega equal to x1 of e power j omega into x3 of e power j omega. DTFT transforms convolution into multiplication. What is x1 of e power j omega? 1 over 1 minus half e power minus j omega into what is x3 of e power j omega? E to the power minus j omega divided by 1 minus 1 by 3 e power minus j omega. This is the end of the solution. So in this problem we have applied time shift property and then we have applied convolution property. Next problem, find inverse DTFT of x of e power j omega equals 3 minus 1 by 4 e power minus j omega divided by minus 1 by 16 e power minus j2 omega plus 1. Solution. Let e to the power minus j omega be equal to b. Then what we get? X of e power j omega equals 3 minus 1 by 4 into v divided by minus 1 by 60 v square plus 1. If you factorize denominator, you get 3 minus 1 by 4 into v divided by 1 minus v by 4 into 1 plus v by 4. Using the theory of partial fractions, we can write x of e power j omega equals k1 divided by 1 minus v by 4 plus k2 divided by 1 plus v by 4. To find k1 and k2, I shall demonstrate for one problem procedure for finding k1 and k2. So what do you get? k1 into 1 plus v by 4 plus k2 into 1 minus v by 4 is equal to 3 minus 1 by 4 into v. Put v is equal to 4. Put v equal to 4. Then what happens? Then this becomes v is equal to 4 means this becomes 2k1 plus 0 is equal to 3 minus v is 4, 3 minus 1. This implies k1 is equal to 1. Put v is equal to minus 4. Then this becomes 0. Minus 4 means this becomes 2k2 is equal to 4. This implies k2 is equal to 2. Hence x of e power j omega equals k1 is 1 minus 1 over 1 minus v by 4 plus k2 is what? 2 divided by 1 minus of minus v by 4. Minus into minus, it is plus. Therefore, this term is nothing but 1 plus v by 4. Now substitute v is equal to e power minus j omega. So what you get? 1 minus 1 by 4 e power minus j omega plus 2 into 1 minus 1 over 1 minus of what I say minus of 1 by 4 into e power minus j omega. Recall a to the power n into u of n will have a discrete time Fourier transform 1 over 1 minus a into e power minus j omega. Hence x of n equals 1 by 4 to the power n into u of n plus 2 times minus 1 by 4 to the power n into u of n. This is the answer. Next problem. Find inverse DTFT of x of e power j omega equal to 3 minus 5 by 4 e power minus j omega divided by 1 by 8 e to the power minus j2 omega minus 3 by 4 e to the power minus j omega plus 1. Solution. Let e to the power minus j omega be equal to b. Then x of e power j omega equals 3 minus 5 by 4 into v divided by 1 by 8 v square minus 3 by 4 into v plus 1. We will factorize the denominator. That gives us 3 minus 5 by 4 into v divided by 1 minus v by 4 into 1 minus v by 2. We expand, we remove the brackets, we get back this expression. 1 by 4 into 1 by 2 is 1 by 8 v square. 1 by 4 plus half is 3 by 4. Now, using theory of partial fractions, using the theory of partial fractions, we can write x of e power j omega equals k1 divided by 1 minus v by 4 plus k2 divided by 1 minus v by 2. Solving, like we did in the previous problem, we solving, we get k1 equals 2 and k2 equal to 1. Hence, x of e power j omega is equal to 2 into 1 minus 1 by 4. What is v? E power minus j omega plus 1 into 1 over 1 minus half e power minus j omega. recall, a to the power n into u of n has a discrete time Fourier transform 1 over 1 minus a e power minus j omega. Hence x of n equals 2 into 1 by 4 to the power n into u of n plus half to the power n into u of n. This is the end of the solution. Find inverse dx problem. Find inverse dt of the x of e power j omega shown in the figure. X axis is omega, y axis is x of e power j omega. From minus omega c to plus omega c, we have got a rectangular distribution. This is minus pi, this is plus pi. Solution. What is the defining equation for finding inverse DFT? X of n by definition is 1 by 2 pi integration from minus pi to plus pi x of e power j omega into e to the power j omega n d omega. This is by definition. We know that x of n by definition. Hence, x of n is equal to 1 by 2 pi integration from minus omega c to plus omega c. This integral is applied to this figure. X of e power j omega is 1. 1 into e to the power j omega n d omega. 1 by 2 pi integrate this with respect to omega. E to the power j omega n divided by jn. Limits for omega from minus omega c to plus omega c. This gives 1 by j times 2 pi n into e to the power j omega c into n minus e to the power minus j omega c into n. This I will rewrite as 1 over pi into n e to the power j omega c into n minus e to the power minus j omega c into n divided by 2j. E to the power j theta minus e to the power minus j theta by sine of omega c into n divided by pi n. N not equal to 0. When n is 0, this becomes indeterminate, 0 by 0. I use the minus. So e power j theta minus e power minus j theta by 2j sin theta. It's minus. Now n not equal to 0. How to find the value of x of e power j omega? How to find the value of x of n when n equal to 0? Two ways you can do by L'Hospital's rule: differentiate numerator, differentiate denominator, and then take the limit n tending to 0. Or this I call equation 1. In equation 1, you put n equal to 0. Letting n equal to 0 in equation 1, we get x of 0 is equal to 1 by 2 pi integration from minus omega c to plus omega c. E to the power 0 is what? 1 d omega. If you integrate d omega, you get omega. So this is 1 by 2 pi into omega in the limits minus omega c to plus omega c. So you get 2 times omega c by 2 pi equals omega c by pi. So this is the value of x of n at n equal to 0. This is how we can find inverse DFT of this rectangular pulse which is in frequency domain using the defining equation.
With this we end DTFT. For additional problems, you can go to the textbook written by me, or I will post some notes in the Google class. Please go through. Thank you.